Hello and welcome back to the Edge and Flow podcast. This is TJ Schwartz. I'm here with my co-host Lucas Burnley, and we on this podcast talk a lot about knives, how to make knives, how we make knives, and all of the things that could have anything to do with knives, like going outdoors, letting our kids play with knives sometimes, and all the fun things. How you doing, Lucas?
I'm doing good, man.
Doing
Your
good.
your voice is very smooth this morning.
Smooth. Uh,
We are recording very early. It is currently still dark here. Um, Needs must. We are both not busy, but this was the time that we could figure out to
mhm.
record. So actually, I'm liking this.
I do. Yeah. The new shop, I don't really have sound insulation, and the office is kind of part and parcel with the whole shop. So it's like it's become a need for us to do this outside of business hours. So I think it's good. I think it's good. Allows me
I
to
almost sent
focus.
you a listing yesterday on Marketplace for a quiet room. It's like
Mm,
like for office buildings where it's like an internal freestanding sound chamber where you can go in and scream.
yeah,
No
that'd
one
be
can
good.
hear you. Yeah.
That's exactly what I need.
Um, well, you want to do shop updates first?
Yeah, let's do it.
All right.
You want to go?
Go. You go.
Okay. Yeah, so this week it's Friday, so that would be my Saturday. But I had a strong week. We all had a strong week. We shipped a lot of knives. Um, say the only thing that's really dragging us down a little bit is we do have a little bit of surface grinding shortage with Ronnie's got that new grinder in there, and he found out, like I said, he's got like 100 wheels that came with
Oh,
it.
wow.
But he found out the hard way that those wheels haven't been used in who knows how long, like some of them maybe like a decade.
Yeah.
And they've been sitting in one orientation for so long
Mm.
that he can't get pretty much any of them to balance. So he's testing different ways of like basically submerging them in like simple green to try to like break up the grease that's in them to like get them sterile enough to rebalance. You know what I mean? Because if you get a wheel coolant wet and then all the water evaporates and then coagulates
Yeah,
for
it just
years, it
leaves
just stays on
particulate.
one side. Um, and so, long story short, he had to order a new wheel. So we have a little bit of a tightness there with not having a lot of surface ground parts, but it's all good. But
I wonder if ultrasonic would work. And this could be
yeah,
like a terrible idea too. Like I don't know enough about structured abrasives like that to know if like you can, but if you like simple greened in an
yeah,
ultrasonic, like theoretically that would
yeah,
I think it would do a pretty good job.
yeah. He said he soaked him in water and it just didn't really do it.
Yeah,
What didn't break it up.
right. Because
Um,
you're not cutting the particulate is still like probably
yeah,
some type of oil based or like mineral based,
yeah. Because the hub has like movable weights on those,
Right.
and so it's like really critical that you balance them because they're 14-inch by 2-inch wheels, so they're enormous. So if it's out of balance, you could have like an extra 2 pounds like floating around on one side. And so he's been battling that a little bit, which, like I said, he ended up getting a new wheel, but it is a bummer to get 100 wheels and then be like, all
No.
right, day one, order another wheel.
Yeah. No.
Like, uh,
It's funny, the microcosms that are in just really any shop work. I was thinking about this. Yeah, you had asked me a laser question, and I had been doing some testing with the laser a few days before, and like I just I just had this realization of like almost every tool in our shops, like some more than others, but like that could be an entire job. And I mean, in different times it has been like if you're a surface grinder operator, right? Which like Ronnie is right now,
mhm.
you just get incredibly skilled at everything surrounding surface grinders, right? And obviously you pick up other things, but like if you're working in a factory setting, you might be on a surface grinder for years and years and years.
Hmm.
Any small shop, we don't have like you don't really have the luxury of that. I mean, you get better just in time,
Yeah.
right? Some people focus on it more than others. Like if you do you follow Alan Olishowitz?
Yeah. Yep.
Yeah,
Yep.
like his process is very, very uh thoughtful in terms of like every machining practice. Like
Mm-hmm.
his skill level at a given task, like surface grinding. Like I always watch him, like he's dry surface grinding hardened steel. And I'm like, I don't know how to do that. He
Mm-hmm.
spent the time to like learn that like very specific skill.
Mm-hmm.
I don't know. It's really fun.
Yeah, yeah, no, that it's an art, man, that surface grinding. I don't have any experience with it, but I just learned through osmosis while he's kind of going
Yeah.
through that journey. And there's so much nuance. He was talking to me about how, so when he freshly dresses a wheel,
Yeah.
the finish, it cuts the best when it's freshly dressed, but the
Right.
finish is not the best when it's freshly dressed, which is a
Right.
little bit counterintuitive. It's a certain number of passes in tenths through the
Right.
material before the finish gets to like where you would call
Where
it
you want
perfection.
it. Yeah.
And so it's like you have to like it's like landing a helicopter. It's like you have to bring it in with a fresh dress, but you have to have enough material left and then descend to where it's like it's hitting the perfect finish at the
Yeah.
same time that you're hitting the perfect depth.
Yeah.
And so when he goes to a new grinder with a bigger wheel, different RPM, a little bit different table speed, that landing process of like when do I dress with how much material left before I hit the right depth at the right finish is like a new calculus.
Yeah.
And it's like, holy cow, that's crazy, you know?
It's deep. And like I think we like take it for granted sometimes. I don't know, this like ties to into like content for me, right? Because like looking at sometimes like what is I posted this like quick reel of my Tumblr yesterday and just with a question. And I was looking at the numbers and I'm like, just tumbling alone, like is pretty interesting. A huge response on the question, right? And then the reel had like over 6,000 views.
Hmm.
But what the image is just like a blue bowl with some like gray rocks in it.
Hmm.
I don't know what makes that track better or like get more
Yeah.
like why it's so sticky.
Yeah.
Tumbling like surface grinding, it's less precision based, but it is no less process based.
Yeah. Same amount of like consequential variables going on.
Yeah.
Yeah.
And like theoretically, you can go to a mirror finish in tumbling, right?
Yep.
The trick and the balance is maintaining like the like shape integrity, right? Or integrity of form while refining quality of surface finish.
Hmm.
There's a lot. Like
Yeah.
it's easy to just like throw a part in and be like, oh yeah, I'm going to a gray and I'm deburring this.
Yeah.
But they are capable of so much. That thinking about two like I don't know, kind of like tangential thoughts here would be like, okay, so the Japanese like sword smithing tradition, right? Where like a sword was made by essentially like five craftspeople.
Hmm.
And then uh how knives are made in Maniago, where you might have a family shop that all they do is mass finishing or laser work. It's like this family has the lasers. And so like now I think it's changed where, you know, the bigger companies have like more machinery.
Hmm.
But I think for a long time, you had like families and businesses kind of like branched off into specialties and created like an ecosystem,
Yeah. Yeah.
which is pretty cool.
Yeah. Dispersed supply chain.
Would you say that Boise has that a little bit?
Oh yeah. Yeah. I mean, yeah, like heat treat and well now Ronnie with surface grinding, you got a bunch of water jet laser shops. Yeah, there's a pretty good dispersal of like a lot of things knives. Funny enough,
Kydex,
yeah, funny enough,
right?
there's at least one shop that's a CNC machine shop that will if they see a part come through and it's a knife, they will no quote it because they've made enough parts for knife makers to know that they should not be in the knife business.
They don't
Yeah.
want to do it.
Yeah. So you know Factor 55 winch hooks, a little bit of a
Yeah.
tangent. It's the
Yep.
company that makes all those because
Oh
Factor
wow.
55's in Boise, but it's an OEM that makes it.
Right.
So they make billet aluminum parts in ridiculous quantities with like robots in front of the machines switching
Yeah.
those hooks
Picking
out.
parts.
And yeah, if you send them like a knife, you like, I don't want the bevel. I just, want a machine perimeter.
Profile. Yeah.
They're like, yeah, sorry, no quote. Like, looks like a knife to us. No thanks. Yeah.
Wow.
And I assume it's because of they've made knives before and they've found that maybe making billet aluminum parts is a little bit more fun
Yeah. And
as
probably
an
more
OEM. Yeah.
forgiving.
Yeah.
Good on them for, I mean,
Yeah.
saying no.
Yeah. Yeah, exactly. And they're a great company. They've done other work for me, but I got a kick out of that in
Yeah.
Boise, you'll walk into some of these suppliers and I'm like, oh, you're one of those knife guys. Like,
Yeah. No.
because I walked into the tooling supply place the other day to buy some coolant, and they're also the Haas factory outlet. I was like, yeah, I need a bucket of coolant. She's like, what's the name? I'm like, Schwartz Knives. And she's like, knives. She's like, are you Chris? And I'm like, no, I'm not Chris, but appreciate it. Like Chris Reeve, because it's like knives, Chris. There's a knife
That's just
Chris company.
instantaneous
Yeah,
recognition.
yeah, yeah. So it's funny how the valley works like that. But speaking of finishing, one thing I had Dalton kind of jump on this week is I picked up some bead media glass bead. We want to mess around with a bead blast finish
Mm-hmm.
as another option for a non-coated situation.
Mm-hmm.
Says our internet's unstable, so hopefully it stays
Yeah, you
solid.
froze up for a second there.
I think we're good.
Okay, sweet.
Um, but yeah, so we're trying out bead blast finishes on Magnacut on our knives to see what the results would be, and mainly I want to know what is the prep work required to have a quality finish. Can you hear me? So we had a little intermission there. Internet went out, but we were talking about bead blasting. So I want to try to get a bead blast operational on Magnacut and figure out what kind of prep work is involved in making sure that the finish is clean, and like, to what degree do we have to finish the bevel? To what degree does it cover any anomalies, scratches? You know what I mean? Like, how sensitive is that finish? So I kind of put Dalton on that for a few hours this week to like, we've got the one blast cabinet, so we had to do some media swap overs to do some multiple stages.
Mm-hmm.
And I did already order another Trinco, so that we
Nice.
could have that, but like a 2 week lead time. So we're just sort of experimenting in the meantime. But I did want to pick your brain about bead blast. We had some good results, but what do you have to say? I mean, I know you've messed with it.
Kind of interesting for you because your process is different. So basic, I would say most blasted and tumbled finishes that you would see in the knife industry can be achieved from about a 400 grit grind or surface finish.
Mm-hmm.
I'm trying to learn more about technical descriptions of finishes. Again, another like rabbit hole.
Mm-hmm.
But I think as a general baseline, like 400 grit is the coarsest you can go into a tumbler
Mm-hmm.
with a given media and not have rounding of the part and
Yeah.
end up, this is kind of what we were talking about
Yeah.
earlier, right? Not start to like have to tumble it so long that you start to round out all your
Yeah.
edges.
Yeah.
400 grit directly into the tumbler may even be a little coarse, but if you're blasting, that's going to cover up. It's going to
Yeah.
refine the surface enough.
So what we're considering is having the bead blast without the tumble be an
Yep.
option.
Yep.
And I was curious, you run some Zerblast, correct?
Yep. Yep.
And that's a different kind of bead blast. What is the consequence of Zerblast over like glass bead? What is the
I don't
advantage?
know that it would serve a purpose, honestly.
Okay.
I would say that Zerblast, in my experience, is giving you a very comparable finish to fresh glass bead.
Mm-hmm.
It just lasts a lot longer. So
Lasts longer.
Zerblast, yeah,
Mm-hmm.
Zerblast is like, it's basically a ceramic micro sphere.
Less prone to shattering on
It does
impact.
not shatter. It does not create dust. Okay.
Mm-hmm.
It is beautiful. So really, in my mind, it's just a better bead blast.
Yeah.
Maybe there's some technical difficulties that like the internet will correct me on,
Mm-hmm.
but it's been in use for a really long time. The first person that I like know about using it was Kit Carson.
Mhm.
Um, and super expensive, but it doesn't, I mean, I've probably been running the same Zerblast for 4 or 5 years.
Mhm.
I could add some, like you lose a little bit over time,
Yeah.
but it works really, really well. I think the question might be if you're going for a certain finish, like one thing you could try is sandblasting before
Yeah.
Zerblasting. I
That
would say is probably a better progression than bead blasting to Zerblasting.
Yeah, Dalton was doing some experimenting, and the bead blast that we picked up did close to nothing to
Yeah.
a non-sandblasted surface. Like
Yeah.
it sort of removed like a little bit of the heat treat color, but
Yeah.
that's like almost it. It just sort of
Yeah.
polished it. It's like
Yeah.
buffing it or something.
Yeah. If you think
Um,
about what's happening, I mean, one is cutting, right?
yep.
So sandblasting on like a micro process is like doing what a belt is doing.
Mhm.
Sharp objects are rubbing over the surface of whatever you're
Yeah.
blasting.
And there is
Okay.
actual material removal
There is
as well.
material removal. Um, with sandblasting, like, a lot, it's kind of like welding. You want like a 15-degree angle. You never want to go 90 degrees to your part
Hmm.
because if you're going 90 degrees, your media wears out faster.
Hmm.
Okay. So you're basically sanding the part, but and giving a very, very uniform finish. Okay. This is also why sandblasted finishes, like if left like alone, rust faster
Yeah.
because you're basically opening
Pores.
up the pores of the steel.
Yeah.
Okay. Bead blasting is more of a peening process, which is why something like Zerblast after sandblast works really, really well because you now have this like freshly abraded surface, right?
Mhm.
That you're going in, and as the beads hit it, they have something to compress.
Yeah. Yeah. Yeah.
That at least is the way that my brain explains it.
Yeah, visually, that seems to be the result we got, blasting
Yeah.
with 100 grit aluminum oxide, which is
Yep.
a coarse abrasive, and then going to, I don't remember the grit of the bead, but a really fine
Probably like a
bead.
B, like a B. Oh, you're not using Zerblast yet?
Yeah, not zerb,
Right.
just
Okay.
glass. And it put a beautiful finish on it. So what
Yeah.
I want to experiment with, like I said, is we do a two-stage stoning on the bevel to take it to a
Hmm.
tumbler. So we do 400 and 600 because we
Okay.
found that with a stone it will leave scratches at the 400 that
At the
tumble
four. Okay.
will not take out. So we do 4 to 6. When we send a knife to Cerakote, we only go to 400 because it gets blasted at like 100 psi to like
Right.
really open up pores, and then it gets Cerakoted, and it's like any 400 grit scratch is like absolute history.
That's a good question. I would ask, like, is 400 even necessary?
It
Like
is.
maybe it's a moot point, like, but 320 would 320 work?
We could definitely go down or coarser on the grit. The only
Yeah.
reason we do it is like when we do our milling on the bevels, we'll get like every knife will get like maybe one line, depends on how dull the tool is, where it's like just a little bit of an extra depth on one pass because
Okay.
either like a chip collected on the cutter or something.
Right.
And
Right.
so what Dalton does when he's prepping for Cerakote is he just looks for lines. And so whatever grit he's comfortable with taking lines out, he seems to be comfortable with the 400 of like he
Okay.
basically makes a pass over the bevel to see if any tooling lines come through. And on some knives there aren't any, and so it's just
Right.
checking it. And then if he
Right. Right.
finds one, just take the line out, and that preps it for Cerakote. But the question I have is, to what degree would he have to prep, and to what grit for our bead blast? Because the
I think it's the same.
stonewash probably is kind of
Yeah.
what we're thinking, because it appears that stonewash is the absolute most sensitive, most difficult, highest requirement for finish on the bevel.
Yeah.
And we're trying to get but everyone wants it on Magnacut because it's not coated and it's a
Right.
stainless steel.
Yeah.
And we were trying to figure out what is another option that is not coated that doesn't require quite that degree of like extreme finishing.
Yeah.
And so we're playing with that, because if the bead blast requires everything that the stonewash requires as far as like input labor,
Yeah.
then it would be cool. I mean, it's still worth it, but it doesn't really help us. Doesn't There's no advantage really, you know?
There's no time advantage.
Yeah.
I would push back against that from the standpoint of like having some aesthetic finishes.
Mm-hmm.
I think there's a lot of value in that. And the bead blast kind of look is so clean.
It is.
I think I think it fits completely inside of what you were doing now. The only reason that I mentioned tumbling Zerblast is because no matter what, like there is a texture even out of Zerblast. Now,
Mm-hmm.
one thought that I've had recently is instead of changing media, changing PSI.
Mm-hmm.
So like the way that I would see this is like you blast, you sandblast, right? And then you go to Zerblast. You have two options here. You could experiment with starting at a low range of PSI and going up until you get the finish you want. Or you could blast at the PSI where you know you're getting like the surface finish, right? Like you know that it is taking out all of the marks from the blast media. And then from there, turn it down
Mm-hmm.
and it might give like a slightly smoother finish. Tumbling, even if it is like 5 minutes, basically just kind of smooths things out a little bit, but it also gives a little bit of this like really subtle, non-uniform finish, which
Like
is what
marbling.
it gives
Yeah.
marbling, which
Yeah.
I love because they're going into Kydex sheaths. You're gonna get snail trails. It's like I get it's a tool. I mean, but I
Yeah.
think in the design process and like user kind of interface stuff, if you can minimize damage in an area, it's not a bad idea to
Yeah.
do.
Yeah,
Right.
exactly.
So
Yeah.
that would
Or
be like my
obscure it.
case for, yeah, like you're like, okay, that's why, have you seen my field wash finish? Are you like familiar enough with
I'm
it?
sure I've seen it, but I don't think I've
Yeah. And basically all
associated.
that is, it's a, I basically pre-finish the blank, tumble the blank. um, Actually it's not super different from like what I'm thinking is on like a Sabenza where they probably like tumble the blank and then finish the grind.
Mm,
I then basically take that satin, the bevel is satin. I throw it in the tumbler and it gives like this two tone where it's like you can see that it's bright,
hmm.
but there's also like this like really kind of like micro scratch pattern across the whole thing. And
Yeah.
it feels like something where has a little more character maybe than just like a flat, stonewashed finish,
Yeah. Yeah. Yeah.
but has the durability also,
Yeah. No,
which I
that's
like.
great. That's great. Yeah. Our current recipe for stonewash is we blast with 100 grit aluminum oxide, but we found that we go at the lowest pressure that will actually feed the gun. So
Oh,
it's literally
interesting.
like hold the trigger and turn the regulator until sand starts coming out, and then that's it. And the reason we have to do that is as the diameter, because the nozzles open up a little bit over
Yeah.
time, and as it opens up, that pressure becomes different. And it's actually the bigger
Oh,
the diameter, the lower the pressure you actually want, because the blast will get more aggressive as that opens up for some reason. And so we actually every time we go to blast blades just check the regulator to where it's just feeding, just bare like three to five psi over where it begins to feed, and then in doing so, we're trying to minimize the depth of any pores that are put into the
right.
steel, and then we tumble it for 4 hours. So we're going for like a pretty glossy, like minimum pores,
Yeah.
and the benefit of that is like peak corrosion resistance that we can
Right.
possibly get. Problem with that is we're not doing stuff that would hide anything. You know what I mean?
Yeah.
Like, and so we have this process where it's like we do a bunch of stonewash. Every batch that comes out, there's like always a couple where there's like a little something, a little scratch, a little 400 grit, something, and then those just get bumped to Cerakote. If either sometimes we'll retumble a knife, but like more likely than not, at that point it's just going to get bounced to Cerakote.
Right.
And it'd be nice, like I said, if we had like if the bead blast would also be able to correct those tiny little things so that you could bump it to that and not have another uncoated option.
It
Um,
might, this, early on, early being relative, but I think there was a kind of a common opinion that like stone washing was like a very basic finish. And the reality
It's
was
hard,
it
dude.
it actually is
Yeah.
hard to do well. There's a lot of
Mhm.
things that were done early on that people just did, but being able to do that well and consistently, like stonewashing accentuates flaws,
Mhm.
right? Like if you
Yeah.
have a scratch and you stonewash it, it's gonna show.
Yeah.
Uh, which I kind of like.
Right.
But
Yeah. And like in the early days, like I found that, you know, you blast something hard, you tumble it
yep,
for like 30 minutes,
yep,
hides pretty much everything.
yep,
But I think I saw some real evidence that that it like the increase in corrosion
yep.
problems is very large. If you,
It's
when I
huge.
do that, it's like it's way more rust prone. So
Yeah,
I just couldn't live with that, and so I was like, over time, I got to where I was tumbling longer and longer and blasting lighter and lighter. So our
yeah,
finishing prep has had to get better and better and better and better to try to
yeah,
achieve what we're doing.
yeah.
It's it works. We're successful at shipping a lot of stonewash knives, but it's like I know people are some of them are only buying that option because it's the only uncoated option,
Right.
and it's like I gotta figure out another uncoated option. So anyway, that's kind of where my
I
head
mean,
was
have
at.
you, so trying to organize my thoughts here. One, that's the blasting concept is actually tip of the day for me because you are doing so much more volume than I'm doing. You're actually seeing the changes real time. Whereas I've got like, I'll blast a bunch of parts and then it's 3 weeks before I blast more parts. You're
Hmm.
actually blasting continually enough to see the changes.
Hmm.
Starting at a low PSI and working up is genius. That it
So
makes perfect sense now that like you've said that.
it was a couple months ago. A batch came out of the tumbler, and I was looking at it. I'm like, it looks different. I was like,
Yeah.
it's not as shiny,
Yeah.
and I'm like, it looks like it was blasted harder. And we look at the regulator, and like it's been in the same. I had a
Yeah.
sticker next to the
Because your
regulator.
flow is going up. So
Yeah,
your orifice is opening up and your siphon is able to push more media
yeah,
through, which is like kind of counterintuitive in a way because I would almost assume that the smaller tip size
would be more velocity.
would be more velocity, but
You
it's
would think.
less overall media
Yeah,
probably or something.
yeah, and
Super
we were
interesting.
looking. The first thought I had was like that regulator is failing, is what I thought. I'm like it's probably putting out more
Yeah, yeah,
pressure than
yeah.
what it says. And then so we started tuning it, and then we changed the nozzle, and it went from feeding well at the same pressure to when we changed to a new nozzle, it wouldn't feed at all because there wasn't enough volume. And so we're like, oh,
That's right.
it was the nozzle. And so now we match PSI to nozzle diameter. And so it was like just a
And that
detail.
never, the beauty of that is it doesn't change.
Yeah.
As you don't have to like be like, okay, we've used this on X amount of parts. Now we have to like increase our PSI.
Yeah.
It's like self selecting. Like
Yeah.
as soon as it's pulling media, you are already at the right
Yeah.
PSI.
Yep.
Okay, that's super exciting. I'm gonna try that.
And you could always also like if you are going to blast, like let's say you're going higher than that, you could say, okay, I'm going to wait till it starts to blast, and then I'm going to go 20 above that or 15 above that or what, you know what I mean? Like that can be your 0 point,
Yeah,
and then you can go up from there so that you have like consistency,
yeah,
if you wanted. But our that pressure for us is in the range of like 38 to 45 psi usually is about where anything below that, and it just there's not enough draw to actually lift the media in a siphon
yeah.
setup. um so
Oh,
it's
I'm gonna have to try that. I want to say I usually run about like 60.
yeah.
Um, okay. Second part of that thought is around blasting media and corrosion resistance. Okay, absolutely. Anything that is blasted with any type, you're getting a surface that is less uh, corrosion resistant.
Hmm.
This is one where I go back and forth on it. Carbon steel knives have been in use forever and ever and ever, right? Like basic maintenance, like people were using carbon steel on, ships out in the saltwatery seas.
Yeah,
Like,
beeswax or whatever. Yeah.
yeah, there's a lot of ways around it. So with like our modern steels, you're still getting a corrosion resistance, even with some type of abraded finish,
Mhm.
or like, tumbling, bead blasting, sandblasting, etc. But that's why I think in like the 1970s, there were so many mirror polish knives.
Yeah.
I don't think it was necessarily an aesthetic choice at first, as much as, hey, we're using these steels. If we mirror polish them, like they don't corrode,
Mhm.
or it's like, think just
It's
loveless,
less
like prime.
likely. Yeah.
It's less likely you're gonna have a knife, you're gonna get it bloody, you're gonna put it in a leather sheath. There's no argument that could be made that like a mirror polished finish isn't going to perform better in
Yeah.
that specific
Yeah.
use case.
Yeah.
Like our generation, I think a lot of our stuff kind of like design cues, processes, etc., kind of come from like the tactical market, which is like, early on, a lot of that was like kind of covert. You didn't want it to be shiny. You didn't want, and they had different reasons for it, and I think this is where doing a little bit of like research around the history of what we're doing is really
Mhm.
helpful, because you just start to see like, oh, why are we doing it this way? And like, does this application suit what I'm doing now?
Yep.
And the like the perfectionist tendencies that like a lot of knife makers have, I think, which is sometimes like, you know, good enough is good enough, or the reason that I'm doing this is a balanced reason. Um, I don't know. I was in the third part of that was essentially, do you think you would ever shoot to do a satin finish or some type of brighter finish?
Um, I I've thought about that. I don't think so. And one of the main reasons is our knives are heavily chamfered,
Right.
and it's not impossible, but to put a true satin on a knife that has jimping, chamfered jimping,
Yeah.
perimeter, bevel, flats, like we're
Right.
talking about extensive. I mean, a
Right.
day of like
Right.
hitting chamfers on like a 45-degree angle, you know what I mean? Like,
Yeah.
and so if we had flat surfaces only
Yeah.
and 90-degree corners, you could easily
Yeah.
pass around the perimeter. You could easily surface grind the flats. You know what I mean? Like there's ways that you could do that, but the chamfers really kill us on
Yeah.
that being an option, which I'm okay with.
Well, it doesn't fit the product. It doesn't fit the
Yeah.
price point. Like it's not necessary for the application. Although that would be a really fun one to build for a show.
Yeah, exactly. Yeah.
Like
Signature
full
custom.
microtech, like mold and die
Yep.
polishing, like everything, just like liquid.
Yeah. Our
All
our
right, Dalton.
chamfers, I've found that our chamfers are a major. It's like you look at a chamfer and you'd be like, oh, chamfer tool and a
Yeah.
CNC mill, not a big deal. The change to our process that are caused by the chamfers is
Yeah.
massive. And
Yeah.
that's one of the reasons. The other reason is we have to have finish thickness in order prior to heat treat, because you can't chamfer and then surface grind. So most knife makers in large manufacturing surface grind post heat treat. So they'll
Right.
machine it and then surface grind it hard. And it's like we can't do that because you're going to lose tons of chamfer parallelism if you chamfer it at a higher thickness and then take the material down. It's going to be almost impossible to manage.
Yeah,
And
you're
so,
increasing your need for dimensional accuracy and
and parallelism.
symmetry and
Yeah.
parallelism tenfold.
And the problem with surface grinding on that is that you don't do one at a time. You do like 20 at a
Yeah,
time. So it's like
it's impossible,
unmanageable.
basically.
Yeah. And so that's where the chamfers are on like our higher end, the Magnacut stuff that we do. That's like it's a huge driver of like how the knife is made to have the chamfers. But I do like the fact that there aren't a lot of fixed blades that have chamfers out there.
Yeah,
I've found it to be actually extremely rare that like a
yeah,
production fixed blade would have chamfers, and I understand why.
yeah,
But that is like with the LT5, with the price point we're targeting and stuff. I did away with the chamfers for the reasons that I said. But that's a price point thing. So it's like I like the fact that our Magnacut stuff has something that is harder to do in a production environment, which justifies part of that, price and stuff.
Yeah,
So,
absolutely. Well, and it's recognizable to the product. Actually, now that you've been doing it, because we've talked like some of the knives that I've done in the past. So when I would hand build tactical, so like the strafe, right? Shadow box scales, chamfered edges.
mhm,
Okay. When I did the Huck, which was a production that Millet made for me, I went to like the radius
yeah,
spine,
which is
which
more forgiving.
I love. So you think it's more forgiving than chamfers?
As far as the depth, like if you're as far as like,
Visually.
yeah, like if it's out of parallel, like if you were to
Yeah.
surface grind it after, it's harder to
Yeah.
see
Yeah.
because you don't have lines.
Right. Lines give you're having like a very specific visual reference point with a line.
Yeah,
Your eye can pick up like a few thousandths.
yeah,
Whereas across a curve, it can be harder.
yeah.
Do at this point, process wise, more difficult or as difficult
For
or just different?
for the radius,
Yeah.
um, like if we were to just throw the radius cutter in instead of chamfering on our end, um, because everything's coming in at thickness, I don't think it would make a difference for us.
Right.
But if for some reason we were like we were gonna have to grind these hard, surface grind them hard, like we might consider going that route because I would say the radius spine gives you a little bit more latitude,
Yeah.
but in our current process, it wouldn't be an advantage
Wouldn't be an
really.
advantage. I
But
still like on the Keyhon, I'm going to start with chamfers, but I haven't like ended on. I really think it's model specific. I think
mhm,
there's models where I'm like, oh, chamfer is going to look perfect on this, and then others where I think a radius just suits maybe like the overall flow.
mhm,
I'm
yeah,
excited. I'm
yeah,
following your advice. I am starting to like shift my schedule a little bit. So like right now, Thursdays are going to be my day that I'm giving 100% of that day to working on the Keyhon and fixturing. And Mondays are going to
nice.
be my things that don't give me dopamine.
Hmm.
Basically, I'm going to try
Right.
it.
There you go. No,
So
yeah, we talked about how the cadence of the
yeah,
operation for me has been pretty important. And I've tried to make everything that I can possibly do on a weekly cadence,
yeah,
as opposed to having some things a weekly thing, some things are monthly goals.
right.
Have it all weekly works pretty good for me.
I think where the one area where it might not work for me is because it's just me. And if I'm splitting my week up, I don't think I could actually finish product weekly, at least not initially,
Hmm.
right? But I think I can do a 2 week cycle, which ideally is where we probably want to be anyway, because we're trying not to like constantly release product on the website. I would rather have every two
Yeah.
weeks having a sale go up.
Yeah.
And if I'm timing the product in some way like that, but ultimately, I think where I was looking at my month, like having production for a month, no, there's no argument that that is too loose because there's too many variables in there for me to be like, well, when is product finishing in that month? Like
Yeah. Yeah.
it's not clearly defined enough.
Yeah.
So, but I did a partial. I didn't get to work on the Keyhon this week, but I did production this week, and I was super efficient. It was really good. I did basically finished. I did Cypops last week. I think I did Polys this week, and I'm doing my goal is to do like 6 SQD mods every
Mm.
month. So after the last round of SQDs, like we got left with some inventory, right? Like there was a market shift in like micro production knives. So the beauty of having finished product is that I can go back in and just like play with it. So
Hmm.
I did for the Brawler Club, I did 6 knives with different finishes. I swapped out parts and did some laser work, and it's really cool. It's like they sell instantly.
Yeah. That's
Um,
awesome.
so yeah, basically trying to like build build the month around that. Like your whole concept of like going in Monday, doing organizational work, ordering, kind of taking care of like the logistics. is kind of how I'm looking at some of the production work that I'm doing right now, where it's like I can actually organize that in a way where it's like clear cut.
Mm-hmm.
Then from there, I have a day or two a week where I can really focus on something that is requiring like much more kind of mental, you know, space,
Yeah.
new things, design things, fixturing. So we'll see.
Yeah. No, I look forward to hearing how that goes. It's a
Me too.
should should be good.
Next week.
Heck yeah. Um, we were going to talk sheaths. Do you want to talk about sheaths?
Yeah, let's get on
Yeah.
sheets.
Yeah. So I've been working on a Kydex sheath for the LT5. Um, it's been giving me a little bit of trouble. This knife is very different than our other knives, and it's vacuum forming, which it's only the second sheath I've vacuum form set up. Um, but it's coming along, and I'm pretty close because the sheath is the one thing in the way of making and shipping these knives. So, um, yeah, we talked a little bit about it before the pod, but getting retention right on such a big knife and getting the form to strike correctly on such a big piece of Kydex
Yeah.
and all that stuff has been interesting. So managing temperatures and stuff, because I found that with a vacuum mold, uh, you do need pretty hot Kydex because you're trying to get it to do some pretty serious articulation to get into the voids that you're looking for. And so you want to go hot, but the hotter you make the Kydex, the more it shrinks. And so you have to make the mold sort of match the temperature, because if you tune the mold at a lower temperature and then you go up on the temperature, then the actual size of the cavity changes, makes it smaller. You know what I mean? So you have to
Right.
be a little bit careful about tuning the mold with, with the temperature being a
Because
part
you're
of
not
that.
molding to, you don't experience that much as if you're molding to the knife.
Yeah.
R-
And
Interesting.
yeah, it's been
And well, and
interesting.
your process, because you're going from molding to CNC.
Yeah.
Yeah. Once again, like your process is finding areas that you really need to focus on that, like if you're doing smaller numbers or a different process, aren't being like exposed,
Right.
which is pretty cool because like the lesson is still there, like
Hmm.
regardless, like you know something about the way that Kydex is functioning.
And
That's
there's
pretty cool.
also there's changes in temperature and shrinkage related to
Yeah.
the color of the Kydex.
Yeah.
So orange Kydex is the
Yeah.
option that shrinks the most that we have. And so we're actually going to probably have to start mapping as we're doing more vacuum molding. We're probably going to have to start mapping temperature to color to get the fit right. And it's very interesting because
That's one I've never experienced.
there's a
I know
couple.
they mold, for me, I would say like they feel different when you're molding
Yeah.
them, which
Yeah.
is makes now perfect sense as to like why there's shrinkage happening.
Yeah, and we didn't when we were doing just knife molding, like you put a knife in a foam press and you do it, wasn't that noticeable. But with the vacuum forming, it's very apparent because if you vacuum form it and you try to put it on the CNC fixture, you get
Yeah.
an immediate reading of like how it fits on there of like, whoa,
Yeah.
that's smaller than the other
Yeah.
ones.
Yeah. Sits up
Uh,
on top or
yeah,
something. And
yeah. And so controlling those, it's interesting. Honestly, vacuum forming sheaths and the fixtures and engineering behind that is the most complicated part of
I
any of
believe
our
it.
knives. It really
I
is.
believe it.
It's
There's, well, I mean, you're dealing with something that moves.
yeah,
And I mean, there are a ton of variables. You don't know the precision of a Kydex melt,
yeah,
or color. So like in my mind, at least I'm seeing like, why is it like, oh, there's probably more pigment or
yeah.
something. And the pigment is affecting
Formulation.
like,
Yeah.
yeah, like how the Kydex reacts. That's another one that just like kind of finishing, like blasting Kydex, early Kydex left a lot to be desired. Some of it was really good. It's easy to do poorly.
Hmm.
And there is a lot of like very poorly done Kydex. To do it well, I really think it yields like a very nice product.
Hmm.
It's still tool based. Like people like with Kydex sheets, it's like the Kydex will scratch. It's not if, it's just a when, right?
Yeah.
But for the types of knives that work in Kydex, it is a pretty ideal solution,
Yeah. Yeah.
right? Super
I
functional.
like it
They're
a lot.
self-retaining. Yeah, it's a
Thin.
really, yeah, super thin.
Hmm.
Um,
Colors.
but there's a lot, yeah, there's a lot to it.
Yeah. Yeah. No, I'm having fun with it. Basically, I've got the scales running for this
Yep.
knife, production ready. I've got the material. Our plan is we have a bunch of the tangs cerakoted and finished, but not sharpened. Next week, I'm going to start sharpening maybe like 25 of them and get them all in a row and make scales one at a time and assembling so that we make sure that there aren't variables that we didn't predict. So if you
Right.
make too many scales and then you try to assemble, we want to
Right.
make sure we're catching variables one at a time. So we want to get like 25 knives built that way as we ramp up and then make like those 25 sheaths. And as each one comes off, put it on the next knife. And that way we're tuning it. Because if you just use one knife and one set of scales and you're trying to tune, you could be missing a whole field of variables as far as like the where exactly the bevel heights are a little different, exactly
Right.
the thickness, the scales vary maybe, so it's like I want to have production data is kind of the next step. So we're pretty much production ready, but we have to kind of tiptoe our way into this ramp up is kind of where
Actually
we're at.
assembly. One thing I
Yeah.
love about the way that you are working is that you are taking parts to a point of assembly. Like I default to my hand skills so much where it's like, okay, if I was doing that, I would probably be like, okay, well, I can do like a quick perimeter sanding pass around the scale to the tang if it's not perfect. But you're not allowing that because you're doing production and you know that that scaled is a terrible idea,
Right.
right? So your process out of the gate is much, much more efficient. That will be something that I actually have to really try to train myself to do. It's so easy to just be like, yeah, no, like, okay, I can move from this point forward because I know I can make a simple correction,
Yeah.
right? This is another area where having like employees, I think really comes into play. It's because as soon as you're not the one like having to make corrections, you're just like creating more working time for other people and like more potential for problems,
Yeah. Yeah. Yeah.
right?
When I built the fixtures, I made sure that the three bolt holes and the perimeters were machined in the same operation on both the scales and the tang, which made for interesting setup on the tang on the fixture.
Right.
But now it's paying dividends because I've made like 4 or 5 sets of scales
Yeah.
and they've all hit perfect. And so the one thing we have to watch though is the tool is going to be wearing on tangs. So the tangs are going to be getting bigger
Right.
as progress happens through a batch by small amounts. Same with the scales. So if
Right.
you take the latter end of the scales that are the biggest and the very first tang that came off the machine, and if there's not a good way to measure like cutter comp on that because it's like it's not a rectangle. You can't just like mic it.
Right.
So I want to make sure that our range of like the biggest scale and the smallest tang, are they going to work? And then how much control are we going to have to put on that? And so that's the variable that I'm watching. But the positional, I think, based on the fixture setup, is not possible for it to move. At least I hope. Doesn't seem like it's engineered so that positionally they're always going to match up. It's just the size. So
Hmm.
we're gonna
Dude,
see.
that's a lot. My brain just had a question to itself because it's noisy. If you wanted to theoretically try to figure out cutter wear and compensation based on a non-uniform part like a knife, right? Like this is one of the things we deal with all the time. Like
Hmm.
there's like very few straight lines, there's very few like measurable things. Like I suppose like some kind of like optical solution probably
Hmm.
is like what like a big shop would do, right? Could you do tests of the same material with the same I'm trying to think, like the same length. So if you were to like unwrap your knife and make it a straight line,
Hmm.
if you were to cut the same length in the same material, but in a shape that was measurable.
Mm,
So like I'm thinking like a rectangle with like a squiggly or same amount of
yeah.
turns. So it's
Yeah.
like, okay, this knife it's doing like this radius, this, so there's eight radii and 15 inches of surface.
Hmm.
If you were to just cut that, would that give you a viable wear
I
like
think
reading?
I think it would. I think if you wanted to map that, you could do like simulations to map it, like what you're saying. Um,
Simulations. Okay. That's like smart.
the I think the route that I'm picturing though is as we start to assemble, I think we're going to see some variability in the
Sure.
sizing. And what I want to do is probably end up with a go no go on both stations
Right.
of there's a tang that's
Yeah.
got a Sharpie written on it like no go. So it's like
Yeah.
when the scale comes off, put it on there. If the scale is smaller than that tang, like if you can feel the tang,
Yeah.
you need to cutter comp, and then vice versa so that we're
Oh,
controlling it.
that's smart.
And so that it's like this is the max and min for both stations, but I'm not going to do that until I know that that is necessary because
Until it's necessary.
if these
Right.
all go together, they go together. You know what I mean? So
I just imagined an EDM'd form as being another
mhm.
option for a
Yeah,
go no gauge. So
yeah,
like you have your EDM to like this is undersized, this is oversized. You
yeah,
drop your tang in this
yeah.
EDM'd form.
And then another solve is spring passes. So I do a
Yeah, yeah,
rougher
yeah,
and
yeah.
a finisher on the steel.
Yep.
If I had too much variability, I would do a semi finish and then a finish. So it'd be three passes.
Yep.
And that's if you do a rougher semi finisher finisher, the amount of variability goes way down. It's like that last one is literally just like spring passing.
Yeah.
And that tool also is not wearing because it's barely touching.
Yeah.
And so as long as you have your tool life mapped where you're switching it at a normal interval, you should be good there. So if we have to, we'll do
Right.
that. And we could do that on the material as well, because it's a 3D machined scale, but the perimeter where it touches the tang is machined two-dimensionally. And then the 3D is designed to not quite make it all the way. It becomes tangent, but it doesn't
Right.
quite make it to the bottom of the scale so that the vertical walls are sort of disguised, but
Right.
they could be finished in the same way. Um,
Right. Okay. Dude, there's so much. There's so much.
a lot of little details. I got to say though, I'm starting a love affair with a handle material called Rich Light. Holy cow.
You love it.
I freaking love this stuff, dude. It's probably my favorite handle material. G10 was, now it is. Now it's Rich Light.
I love I love when because Richlight is like a fairly basic material.
Hmm.
I love when people love basic materials because a lot of times they actually work the best
Hmm.
and they look really good. I feel like there's this like, especially on like the custom side, there's this like arms race of material uniqueness that is happening towards like like the question of like you can, but should you is like real where it's like yeah, but does it look good?
Yeah.
Like I get that you have all these fancy materials, but like do they look good together?
Yeah. Yeah.
And that's maybe like a personal opinion, but I love like for me like I always love natural canvas where
Natural
it's like
canvas.
it's
Yeah.
the simplest looking material, but you put it on, you're like, yeah, but it's just like it just looks
It's just
good.
clean. Yeah.
It's super clean, it's super functional. Rich light I've used a handful of times. I love working with it. I don't have enough experience in what like I used some stuff that was like this like two-tone, so like had like
Yeah.
big layers.
Yeah.
What are you using color wise?
So on this first run, it's
Yep.
solid black on the
Yep.
scale. They have a lot of different options. We've done some other layered stuff. But the solid black, here's one of the things I like about it. It's got a warm feel like micarta,
Mm-hmm.
but it has the perfection look of G10. So it's like it doesn't have anomalies because it's so
Oh,
stable.
yeah.
Micarta is amazing, but in production, micarta is frustrating because it's
Right.
very irregular.
Yeah. Your
So
weave is like if you're listening, which you are, micarta has like a larger weave. You have
yeah,
linen micarta and canvas micarta are the two most common. It's basically layers of cloth with a phenolic resin in there. So if you imagine like taking, cloth and just like impregnating them with resin, the way that weave is and the inconsistencies are going to create little pockets where there's like slightly more resin or slightly more cloth. And
Yeah.
as you're cutting that with something like an end mill, it's not perfectly uniform.
Yeah.
Whereas G10, very small pore size on the cloth itself, super uniform.
Yeah. And the resin and the fiberglass in G10 almost is homogeneous looking. It's
Yeah.
like it's like you don't really see it.
Yeah.
But with the rich light, it's even more homogeneous. It literally looks to me like you like plasti dipped it perfectly or like spray painted it matte black. There's like
The
nothing to
matte
speak of.
blackness of it
Yeah.
is amazing. I've noticed that every time you've held up the LT5, the quality of the black is super noticeable.
I'm like stunned by it, to be honest. And the other thing is it doesn't gloss out with wear because it's paper. So it's like if you take a piece of like black construction paper, which is basically what this is, and rub on it, like it doesn't turn like gloss. You know what I mean? It's like it's paper, it's matte. Whereas G10, if it's matte black because you blasted it perfectly,
Yeah.
wear will actually polish it over
Yeah,
time.
absolutely.
And so
Same. Yeah. Micarta G10 both do that.
yeah, and so this it like doesn't polish really because it's actually matte like through and through. You know what I mean? So
Oh,
it does a little bit, but not
sure.
nearly as
Yeah. You
much.
could obviously like you could polish it, right, if you
Right.
wanted to,
Right.
but in day-to-day use, you are seeing less of that.
Yeah, it stays matte. It more securely matte finish. And then the other thing about it is it produces when being milled like on a CNC like close to zero dust
I'm sold. That
because
actually, I'm sold.
it for the chips like so here's an example like if I take a piece of G10 and I
Yeah.
put it on a table saw or a chop saw,
Yeah.
it literally is like a plume. It's like somebody with a vape, like, and
Yeah.
it's like just
And it's fully
yeah,
like
it's like a
carcinogenic.
smokestack coming out
It
of that thing.
so I have a hatred of G10, but I think it comes from like the material itself is great. I like the way it looks.
Mhm.
I worked so much of it by hand. Dude, it makes my skin itch.
Yeah,
Like I know I've always been very cautious in the shop. So like as far as like dust control and just like being aware that there's certain things that while all particulate is bad, I don't
hmm
want a bunch of glass fibers in my
yeah,
lungs.
yep.
And then this is a big and. There's a lot of places that will fully 100% not put G10 on a CNC machine,
Oh yeah, for good reason.
right? Because
Yeah,
it's an embrace. Same with carbon fiber.
yeah.
Um,
But if you take the rich light and put it on a
yeah,
chop saw, what
it's
comes
like cutting
out?
wood.
It's no, it's way less dust than wood.
That's
It's
amazing.
it comes out as like literal chips. It's like if
I
you were to
know this. It's like curls,
yeah, if you were to
right?
take wood and soak it in water
Yes.
and then cut it with a saw,
Yeah.
that's what it looks like that's
I
coming off.
do. I remember that even just from drilling it.
Yeah.
Like you get these like perfect little chip curls.
Yeah.
It's like a plasticized wood is
Yeah,
what it
it's
feels
like
like,
cutting
right?
Delrin. It has like a
Yeah.
Delrin like chip structure as opposed to
What
dust.
what colors is it available in from like a solid color standpoint?
So from a solid color standpoint, they have like a natural that's like a natural linen that's got kind of like that brown look. They got I mean there's a bunch. They've got probably they don't have any high vis stuff. It's all earth
Okay.
tone. So
Do they
that's the
do like an
one.
olive drab?
That's the thing is I don't think I've
I don't
seen
think.
that. Yeah, but they have some layered stuff.
Okay.
But long story short, dude, I am pivoting to rich light in a lot of ways here because
Yeah.
I love it, dude, and it's pretty
Yeah.
affordable, and it just I haven't seen
Suits the
issues.
product.
The finish it blasts like we
Yeah.
blast it, it looks amazing.
I love that.
And the thing about G10 too is I do love G10, but you can overblast G10 really
Yep.
easily because you get as you blast it, the glass stays and the epoxy leaves, and so you get like a crosshatch that remains. And if you blast it too hard in one area, you get like this weird like weave pattern that is kind of strange. But if you blast it
Yeah.
a little bit, it's perfect. The
Right.
rich light, I was experimenting with pressure. It's like blasting it at like 50 psi versus like 100 psi is almost no difference. And you
Huh.
can literally sit in one
It
spot
makes sense because
and
it's a super tight
yeah,
weave.
it
Yeah.
It just doesn't do it. Like it does, the blast only makes it matte. It like doesn't remove material. So it's like you
Love
can
it.
kind of the idea that we have is we that Trinco that I ordered, the sandblast
Mm-hmm.
cabinet, you can get the tumbler blasting system.
Mm-hmm.
And I've never really thought that much about that because I have a suspicion that if it was G10, you would overblast areas.
Right.
Whereas with the Richlight, it seems so much more robust as far as resistance to
That you might
deformation.
be able
You
to.
might be able to put like 10 sets in a basket that's rotating and then have a blast nozzle just blast them on a
It's a weird
timer.
shaped part.
It is.
I don't know that they would tumble. My fear would be that they would not tumble
Yeah.
uh consistently
Yeah, that's
because they're
valid.
flat. They'd stick together. They'd roll over a few times
Yeah.
together.
Yeah. You're probably right. Yeah.
I think like the way to do multiple parts is probably some kind of lazy Susan.
Yeah. That's what
You
Chris Reeve
know?
does.
Yeah, that's like the Chris
Turntable.
Reeve method,
Yeah.
turntable in the center.
Yeah.
Because that way you're not having to like hand hold everything
Yeah.
and you're able to get the same angle every time,
Yeah.
but still be very efficient and like fast through it.
Yeah. Yeah. Might have to try
Dude.
something like that.
Okay.
But
I'm gonna
dude,
have to revisit Rich Light.
try some Rich Light. Because the reason I got onto it is I ordered from a material supplier some like micarta or G10, and you know how some of them will throw in like a
Yeah.
sample. They threw in a sample piece of Rich Light, and I looked at it, I'm like, sure, whatever, we'll make a set of confidant scales. We ran it, same program, same feeds and speeds, and I was like, that looks awesome. Like I'm totally stunned by how impressive that is because it was the layered stuff, but I didn't even know it was layered until we machined it. I didn't even look at
Yeah.
it. I just threw it in the machine,
Yeah.
and it was like, wow, that's beautiful. So we sold that as a signature custom, and I was like, I put that in my back pocket. Like the LT5 is going to be
Yeah.
Rich Light. Like
What
so.
do you have any kind of not an ETA, right? But like do you have a goal? Like is there a date you would like to release the LT5?
So if I was willing to not put any kind of belt attachment on it, I
Yeah.
could release it like next week,
Yeah.
but I'm not willing to do that. And
Yeah.
so we are going to be waiting for the development and production to finish on the leather loop apparatus that we're coming up with. And so we are literally looking at probably having knives and sheaths that are ready to go out the door within the next 10 days that
Oh
will
wow.
be waiting for loops.
Yeah.
If I have a loop that I'm 100% certain is the finished design and photograph ready, I may be willing to do the like a pre-sale that's like the knives are sitting here,
Right.
the loops are getting like the cutter is getting made for the hydraulic press to make the loops. I may sell at that point those ones that are finished. I haven't decided yet, but it's that leather loop is probably going to drag this out. It's probably going to be like a month, honestly.
It's like the little details that
Yeah.
make things complicated. I was just wondering if it was going to be like a Blade show release
Before that for sure, and
before
we'll
that.
definitely try to have some at Blade.
Nice. Okay.
Getting close, but
Dude, um I am I'm getting ready to duck out of town. I'm pulling the boys from school today
mhm.
and we are going to take off for the coast. They're getting ready for spring break, so this is like a pre-spring break. That'll be fun. We're just going to go camp at the ocean for maybe a day or two.
That sounds great.
And dude, I'm very excited. We gotta do this. We gotta get the kids together and go
Yeah, we
camp.
do. Go to the ocean.
Um, go to the ocean, or I'll come out. I need to come out
Yeah,
to you. So,
yeah.
you want to wrap this? I want to get on
Let's
the road.
let's wrap it. Yeah, man. You have
All right,
fun
all
and
right,
drive
man.
safe.
Thanks, guys. Appreciate y'all.
Appreciate it. Catch you later.